For questions 13 and 14, the heading is asking us to find the value of each variable, which is x in this case. We have 4 to the power 3x minus 5 equals 32 to the power of 2x minus 4. In the worksheet, that was written as a minus. I'm sorry about that. That was a typo. The correct way, it's equal to. So if you were working on that question and you didn't know how to do it, you can pause now, do it with the equal sign, and then continue the video to check your answer. In order to solve the equation, the exponential equation, I have to make sure that the base is equal to the base on both sides of the equal sign. How do I do that? We use prime factoring. I'm going to create a box on the side to prime factor the 4. 4 is 2 times 2, which is 2 to the power of 2. We're going to prime factor 32 as well. 32 can be broken down into 8 times 4. 8 can be broken down into 4 times 2. 2 is prime. This 4 can be broken down into 2 times 2. The 2's are prime. And this 4 can be broken down into 2 times 2. The 2's are prime. So here I'll have 1, 2, 3, 4, 5 2's. So 32 is equal to 2 to the power of 5. So instead of 4, I'm going to write the 2 to the power of 2. I'm sorry, I did not write here to the power of 2. Instead of the 4, I'm going to write 2 to the power of 2. In parentheses, outside the parentheses, I'm going to write down 3x minus 5 is equal to, instead of the 32, I'm going to write the 2 to the power of 5. In parentheses, outside the parentheses, I'm going to put 2x minus 4. Now I have a power to a power, which means I'm going to multiply the exponents. Since 3x minus 5 is a binomial, then it must go in parentheses. So it's going to be written as 2 parentheses 3x minus 5. I'm going to use the distributive property. 2 will be multiplied by 3x and negative 5. 2 times 3x is 6x. 2 times negative 5 is negative 10. So this will be written as 2 to the power of 6x minus 10 equal to, I'm going to multiply these two exponents as well. 5 multiplied by 2x minus 4. I'm going to use the distributive property one more time. 5 times 2x and 5 times negative 4. 5 times 2x is 10x, and 5 times negative 4 is negative 20. So it's equal to 2 to the power of 10x minus 20. Now, since the base is equal to the base, so I can cross them out, and that tells me that the exponent must be equal to the exponent. So I have a proper normal equation like the ones we did in middle school. 6x minus 10 equals 10x minus 20. I put a line under the equal sign, and I try to put all the variables on one side. This 10x needs to go to this side, so it's going to jump with the opposite side, which is negative 10x. And now it doesn't exist on this side. Negative 10 needs to move to the other side, so I'm going to do plus 10 on the other side, and I'm going to cross it from this side. Now I'm left with 6x minus 10x, and that gives me negative 4x equals negative 20 plus 10, and that gives me negative 10. Since I have negative 4x and I want to end up with x, so I'm going to divide this side by negative 4, and I'm going to divide this side by negative 4. These two will cancel out, and I'm going to be left with x equals negative divided by negative. They cancel out. 10 and 4, both of them can be divided by 2. So it's going to be 5 over 2, which is the same as 2.5 or 2 1/2. If you just leave it as 5 over 2, it's acceptable, and that's the correct answer.